Hello, everybody. On this Memorial Day, I have taken the time to work all the bugs out, and I'm proud to announce that all bugs have been squashed, and I have successfully tested the security of my security system. And it's not quite finished. There's still some errors, there's still some failures, but I'm about to show you and demonstrate what I have so far. So I always clean my solutions. I'm going to clean the solution. Okay. Solution's been cleaned at 525. We're getting there. Takes forever after a clean. Come on now. Okay. I'm going to have to pull the window. Hey. So you'll notice here, grand total 189 out of 196 tests passed, which is a 96.4% pass rate, which is good. However, it's giving me this warning: some tests failed, review failure before deployment. And basically what I've got here is a little test suite. And so I guess I should start off with, let me pull this over here so you can kind of see what's going on. So these are the actual tests that I've written. And essentially, yeah, from here to here. So essentially what I'm doing is I'm testing this alert level. See, alert level, access level, which is another enum. But it's not just the enums I'm testing, right? It also tests, you know what? Let's just show you what it tests. So it starts with the security enumeration foundation tests. It's just making sure that, that the permissions work and et cetera, et cetera. So that's these. They all pass. The alert levels, the error severity, the health status, all of these pass, as you can see here. But like access type, iterator type, they all pass. And basically what these tests are doing is everything that I've just now created, it's making sure it works. So in these enumerations, it's just making sure that when you print out pointer state, or whenever you print out access level, it prints out the right thing. That's essentially what it's doing. Let's see. Optional state, transition phase tests, they all pass. Validation type, value category, iterator lifecycle state. Now these are all the enum phases. So all of them pass. Now, this test suite doesn't just run the tests on those enums, right? Because you've got an O2 core security. Hang on, let me close some things up. Because This test file tests everything in here. As you can see, access type, iterator type, pointer state, pointer type, right? So this is has tested all of that stuff. It works. And I also am testing the registry system, access pattern, threat indicators, pattern rule, normal behavior profile, right? Because if I'm building Guardian security and system and it doesn't actually work, like for example, there was an error earlier. It no longer fails because I corrected it, and I'll show you the chat that got that fix. So yeah, if you'll notice, let's see, access control entry permission tests. And basically it's making sure that the registry is secure. The core control registry, I should say, using access control entries. Registry entry tests. Of course, these all pass. Security descriptor tests, audit record tests, and of course, all pass. Now, where I had a failure, and it was a critical failure, let me find it. Hold on. Permission tests. This right here. This test failed. That's kind of critical. That means, the reason it was allowing it is because of the function. So let me crap. Where are you at? There you are. And of course, I've asked. I'm gonna go up. Hold on. And of course, this is the chat that I've had to help me solve these issues. Okay, so I asked it, like, I was like, because I ran the test, and I had this code that AI had built me, and it obviously no longer fails, right? I have it passing. I'll show you. See, 4 out of 4. But it was a failure, and it was a critical failure. And I couldn't for the life of me figure out why, test unauthorized user denied. And then I asked it, is a critical security? Because it is. I mean, basically, if the unauthorized user isn't being blocked, the entire security system is what's the point in the security system if anyone can get in? And that was exactly what that failure meant, that anyone could compromise Guardian. So what I had to do, and it was like, well, let me examine this test, and it did that. The test expects unauthorized users should be blocked from both set value and get value on test key, but it's failing. And it says, which means either the set value is succeeding when it shouldn't, or the get value is succeeding when it shouldn't. Let me check the control registry check permission logic. And then it found the bug. The problem, it says, when you try to access test key, there's no security descriptor for it yet. It doesn't exist in the security descriptors map. So the function returns true, allow access. This is a security hole. Any key without an explicit security descriptor allows everyone full access. So it was something I had put together, of course, with the help of AI. So AI kind of sloppily put it together, of course. But it's a security hole. And I'm glad I detected it early on. Because, I mean, so it basically, any key without an explicit security descriptor allows everyone full access. And that makes sense. I mean, if it's designed, So here's the proper fix. And basically it walks up the chain. It's a pretty long fix. See, it walks up directory hierarchy, test key, test, looking for a parent security descriptor, respects the inherent permissions flag. If a parent allows inheritance, it uses its descriptor. It denies by default if no descriptor is found at all, secure by default. The root descriptor you set in the constructor lines 375 through 381 has inherit permissions equals true, so it will be inherited by /key tests /key. And that's, of course, because I built that registry. And I'm still trying to understand that registry, and I may ask it, but you know what? Let's do that. Okay. Let's ask AI. Yeah, unfortunately, I've used a lot of data this month. Okay. Yeah, I don't want to see you. Okay. So basically, I asked AI to kind of, go more into depth about this registry that I built. It's a key system. So if you have the authorization as an admin key, you're allowed into the system as an admin. Does that make sense? I hope that makes sense. Um, so here we go. Explaining the test key registry entry. What is it? What is it? Test /test/key is a hierarchical registry path in the Guardian security system, similar to Windows registry paths or file system directory structures. It demonstrates the hierarchical well, I cannot pronounce things today. Permission inheritance model. Path structure breakdown. Test key. Root level this is the root level, has a default security descriptor. Test. Parent directory namespace key, the actual registry key entry. So how does the security work? Hierarchical inheritance. The root // has a default security descriptor set up in the control registry constructor lines 375 through 381. This root descriptor has inherit permissions equals true. When you access /test/key, the system walks up. First, it checks /test/key for a descriptor, not found. Then checks /test, not found. Finally checks / and it's found, and it allows inheritance. Test /test/key inherits the root's permissions. So the fix we just implemented, the critical bug fix, ensures before the fix, missing descriptors were being treated as allowed by default, a security vulnerability. After the fix, the system properly walks the hierarchy and denies unauthorized access by default. If that makes sense. So why does that matter then? Security guarantees. Explicitly denying overrides allow. If any level in the hierarchy denies access, it's denied. Inheritance control. Parents can control whether children inherit their permissions. Secure by default. Unknown users are denied unless explicitly granted access. Path traversal protection. The hierarchical model prevents unauthorized access to child keys. Use cases. Configuration management, app, database, connection string, could inherit read-only permissions. secret storage, secrets, API keys with strict access control, feature flags, features experimental mode with different user access levels, machine learning model registry, / models / productions / best model with audit trails. So, I mean, it basically. See what it's got to say there. It got confused. I think it got confused. See, I love it. It just like explains everything. You know what? See, this is why I love AI. Because I just ask it questions and it just does things for me. Okay, so let's go through this, I guess. Basically, I was trying to understand. I was trying to explain it to y'all, and I think it can explain it better than me. So let's go all the way to the top. All the way to the top. Okay. Now that you understand the registry a little bit, let's go ahead and look at the entire. So Guardian is a security system. And what I've built in the beginning now, I haven't built Guardian yet. I have only built Guardian's Guardian, if that makes sense. So essentially this is kind of like a firewall for Guardian, and it protects the system. So here goes. Um at the heart of the system is, of course, the control registry, like it says here. Is the central security coordinator that manages, of course, and this is, it shows us here what it's managing. These are maps. This allows for key pair values, key value pairs. Who can access what, find all the key. It's a multi-map. And then, of course, monitor everything that happens within the core control registry, because the control registry is kind of the centralized thing in the whole system. So reader, writer locks, shared mutex for concurrent access, atomic flags for lockdown state, thread safe emergency response, which it does have that. Hopefully I can, hopefully, AI is explaining it better than me. So here's okay. Oh, yeah, here we go. I was looking through the example and it was kind of like giving me not none. Okay, so let's imagine this is tries to access sensitive data, but like imagine someone tries. Uh, step one, you set up the registry, right? Yeah, control registry. And then you take the registry and you set a value. You set the security descriptor. And then here's where the attacker attempts to access the data, right? So what's happening internally? The find descriptor for database credit cards is found. It checks if the inherent permissions are needed. No descriptor exists. Is user the owner? No. Attacker not equals admin. 4. Pass 1. Check deny aces. Found. Attacker permission read. Is denied equals true. Required permission read. Deny ace covers read. Return false. Log audit trail. User attacker. Operation read. Success false. Severity critical. Update threat indicators. Unauthorized accesses plus plus. Total threats plus plus. High severity threat plus plus. Basically, those are variables within threat indicator that hold a value, right? So you can increase those if a threat happens, and it'll keep track of how many threats happen. And of course, that's what happens. And then it checks the threat level, calculates the threat level, returns alert or higher, requires immediate action, true. Triggers log alert, notify security team. Result, after all of this, the stolen data, so the attacker's stolen data, is null opt, which means access denied. Basically, he gets a null pointer, which means he's not getting anything. Now, the policy engine, which is in what enforces the rules, you have a registry policy called system protection, policy name, system, of course, system key protection, the target key pattern, regex, all under system, allow creation, allow modification, allow deletion, require audit, etc., etc. And then, of course, I got an audit trail system, which allows you to audit within the registry. Lockdown mode. Ooh. And what's really cool, so if the registry notices, or if the system notices on invalid access, it immediately puts itself into lockdown mode. So here's a complete attack scenario. Multi-stage attack detection. Stage 1, reconnaissance. Attacker.query/database. And that, of course, will log a query attempt. Unusual access patterns. Brute force. For int I, so basically for 100 times, the attacker tries to access the admin password, denied each time. Brute force indicators goes up, unauthorized access goes up. So it's the system is indicating that there's been an unauthorized access into Guardian. After 10 failed attempts, of course, calculate the threat level. And of course, that'll return alert level. Of course, then this will requires immediate action, which will then return true, because that is how it is. Stage 3, exploitation attempt. Attacker.send payload. And then it sends that text. Drop table. This is like an SQL injection. The injection attack signatures goes up. It calculates the threat level and returns alert level critical. The Boolean function should quarantine, which is within the security system. I got to remember, within the core registry. So the registry has, not only does it have this lockdown mode, but it also has an ability to determine whether or not the system should quarantine. In this case, it does. It returns true, so the system enters lockdown. Stage 4 quarantine, which then enters lockdown mode, and then, of course, the reason SQL injection detected, or it could be anything. It could be invalid access attempt, etc. And then from there, it goes to an all attacker operations. All attacker operations are blocked. Security team notified. Forensic audit trail captured. Part 9, security guarantees. The 5 pillars. Number 1, secure by default. No descriptor, access denied. No matching ACE, access denied. Unknown user, access denied. Number 2, explicit deny wins. Number 1, deny aces checked before allow aces, which is those allows the control entries. Single deny overrides any allows. Order independent evaluation. Number 3, hierarchical inheritance. Children can inherit parent permissions. Parents control inheritance with inherent permissions. Root descriptor provides baseline security. Number 4, comprehensive auditing. Every operation logged. Failed attempts tracked. Threat patterns detected. Number 5, defense in depth. Access control, who can access. Threat detection, identify attacks. Policy enforcement, rules compliance. Lockdown mode, emergency response. And basically, that's what it's doing here. So let's just run through these tests, right? So there's How many are there? Let's go to the end. So there's 196 total tests. And this is the grand summary. Now, you'll notice the security itself is passing. Control registry passes. The threat detection passes, which I just made it pass. Pattern rules, they don't, I've got one failure there. I've got a couple failures in the firewall. Obviously, these are all critical failures. So let's take a look at what's failing. Let's start with pattern rules. It says phase 5A, 19 out of 20 passes. Let's see, that means there's one failure. Let's see. Finding it's going to be the fun part. I think that said 5A, right? Yeah. A statistics test. Hmm. I'm going to ask it. This is why I love AI. And it'll look through all the code. And I can verify that this is going to be an accurate response by retesting it and see if the failure goes away. Test more file more specifically. I think it's confused again. But that's, why are you searching there? It gets confused all the time. I mean, you really got to give it credit though. Thousands and thousands of lines of code that I'm asking it to search through to help me write this code and write these tests. I mean, it's pretty epic. Do I have to give you exact lines? Sometimes I have to, but maybe not this time. Hold on, let's see what it does. Uh, why are you going to other files? Oh, I'm so confused. Mm-hmm.